So CDP is very useful, but CDP is proprietary. Shows CDP neighbor as an example, shows me that my local device is shown in the list of neighbors. That is the local router. Notice the IP address of the local router, and that's the IP address shown in the neighboring output. And that's typically because there is a non-Cisco device in the network that is forwarding CDP messages. So the router is actually seeing itself through the network because there's a loop somewhere, or there might be another problem. So how do I see neighboring devices that may not be using CDP? In other words, non-Cisco devices. Well, I can do that by enabling LLDP. Now this router doesn't support LLDP, but as an example, if I telnet to my 3750 switch, so let's have a look at the details. Here's its IP address, and I'll telnet to it. This switch, which is a physical Cisco switch, so this is not a GNS3 switch, this is a physical 3750. So we can see various physical interfaces on the switch. This switch does support LLDP. Notice I can type LLDP run to enable LLDP on the switch. So show CDP neighbors shows me my Cisco devices, but notice show LLDP neighbors shows me non-Cisco devices, including a Dell server and Ubuntu hypervisor server. So these are Linux-based servers running in my local network. The Dell server has two connections to the switch. So the local 3750 is connected to the Dell on both Fast Ethernet 024 as well as 023. The Ubuntu server is connected to Fast Ethernet 1019. Let's look at details. So show LLDP neighbors detail. I can see that this is a Dell server. It's using Ethernet 1 to connect to the switch. Scrolling down, I can see that the Dell server is connecting via Ethernet 0 to the local switch as well. So the Dell server's got both of its Ethernet network cards connected to the local 3750. I'll do that command again. So show LLDP neighbors detail. Notice we can see the IP address of the Dell server. We can see the operating system on the Dell server. It's running Ubuntu 14.04. It's an x86 64-bit operating system. We can see the options for physical media capabilities. So it supports gigabit Ethernet running at full duplex. On this Ubuntu server, it's connected using port P2, P1. This Ubuntu server is actually running a virtual box in Ubuntu and has various tagged interfaces, hence this interesting name of an interface. This is the IP address of that Ubuntu server. So in the same way that CDP allows me to see information between Cisco devices, LLDP allows me to see information of non-Cisco devices. In my GNS3 topology, I could run LLDP on these switches. So on switch 1 as an example, I can type LLDP run, no CDP run. So I've disabled CDP on switch 1, but I'm running LLDP on switch 1. On switch 2, I'll enable LLDP and leave CDP running. So on switch 2, show CDP neighbors, I can see various Cisco devices. Notice switch 1's timers are less than 120 seconds because they're timing out. So the CDP timers are timing out. But show LLDP neighbors shows me switch 1. So I can see switch 1, but I can't see switch 3 and switch 4 because switch 3 and switch 4 are not running LLDP. So as an example, on switch 3, show LLDP neighbor, we can see that LLDP is not enabled, but CDP is enabled. And we can see that switch 1 is going to time out, whereas something like router 1 has been reset because of the CDP updates. So you can run CDP at the same time as LLDP, like I'm doing here on switch 2. CDP will show me devices that are running CDP. LLDP will show me devices running LLDP. So in a moment, switch 1 is going to time out as it's done here. So we don't see switch 1 through CDP, but we do see it through LLDP. Remember, LLDP is most useful when you have got non-Cisco devices. So like in this example on a 3750, I can see Linux-based servers that are running LLDP. I'd also be able to see devices such as Cisco IP phones running LLDP, as well as non-Cisco routers and switches from vendors such as HPE. Link Layer Discovery Protocol is essentially an industry standard version of Cisco Discovery Protocol, or CDP.